Wanted to give a lab tour for the people that couldn't be here, but were curious about what I've been up to. So this is my quantum lab as it's currently set up. It's took me most of this last year to get all the materials together so I could get things running. Right now, I'm able to generate entanglement and measure coincidence counts, which is basically the measure of success for entanglement. It's all light based. I'll go over a little bit of what you're seeing, so it'll hopefully make a little bit more sense. The big black box is currently shielding two single photon detectors. So if I open this up here, you can see both of them. They're both currently turned on, so we wouldn't have to wait for the video for them to cool. Right down here, there's a 5 micron photodetector. We've got focusing lenses, and all the cables are really just, like here's the fiber that's incoming, where the photons come in. The loose blue cable is a polarization maintaining cable that's just not in use at the moment. We've got power, electrical, got power, USB, and electrical signal going out. But I have to keep these completely shielded and in as much darkness as possible. Both of them get cooled down to negative 40 degrees. Even with all the lights off, the ambient room, and the temperature, it causes what's known as a dark count, where just the thermal energy that the detectors are in cause triggers, or basically false positives. And I'll show you that in a bit. So the laser, I'm gonna turn it off actually, real quick. There we go. So the laser's in here. It's a class 3 laser, but with the metal casing, it's class 1, so it's the same danger as, like, you know, a CD player or something like that. Again, a lot of loose cables. This is just a alignment laser. It's not doing anything. These are 2 fiber coupled photodetectors that I'm trying out. I bought them recently to replace this, so it'll shrink my footprint. I haven't tested them out. I just got the software license to work with them, but they're set up here as well. So in here is the laser. The beam comes out, it goes through a crystal which splits the energy of a photon in half and creates 2 new ones, which are entangled, and couples them out through these two fiber cables that are spooled here, and then those go into the detectors. The SMA cables, these blue cables, are just the electrical signal detection. They come up here to this id Quantique time controller that basically correlates the electrical signals from the detectors to know, so it can understand when coincidence actually happens. And then all of that is fed over to my laptop where I've got the software set up. So I'm gonna go ahead and turn off the light and shut the door. And let's turn the laser on. So I got it set for 35 milliwatts. I'm gonna turn this on. And actually I'm gonna turn it off again and show this. So this right here, these 2 numbers are kind of jumping around. Those are what the detectors are currently detecting in the input 1 and 2 channel. And that's really just dark counts from the thermal or electrical energy in the detectors themselves. That's how sensitive they are. So I'm going to turn the laser on and you'll see these numbers jump. There you go. So they went from about 1,000 to over or close to 200,000. That's just, those are single photons that are coming in. And now this software is what controls the timing device. So we're going to start measuring coincidence here and see. I'm going to show you how much entanglement it has. So that distribution is going up, and so right here we've got at 0 is the time delta 0, and then there's kind of a little bit of drift, and this is in the picosecond range right now, which is a thousandth of a billionth. So it's a trillionth of a second drift, or rather, this is at about a nanosecond or drift. So anyways, I'm integrating over about a minute. Coincidence counts are currently at 130, 150,000. I'll just let that finish up. But essentially what this is measuring is, even though we're seeing like, 200,000 photons a second hitting the detectors, the ones that actually coincide with each other that you would get from an entanglement event is considerably less. There's a lot of other factors that play into that, and there's quite a lot I can do to increase this, but in the early days when I first got it running, I was measuring in the hundreds, and now I'm measuring in the hundreds of thousands. So that's done integrating there. I'm going to turn the laser off. Where'd you go? Boo boo. There we go. We'll see that count drop back down. There we go. Cool. All right. That's it. I mean, that's pretty much all that it can do at the moment. It's a huge achievement, but next what I'll be doing is I gotta test those guys out and see if they're any better. I'll end up using all the detectors to some degree, but I don't have much experience with different devices. The next I'll be basically injecting a lot more optics in between this and the detectors to control the signal and manipulate it and demonstrate different properties of the light when it's entangled and kind of the quantum nature of light. So anyways, that's the lab. Hope you all enjoyed it. Please.